So trig substitution method. So what we did in class was we looked at, first of all, what is the derivative of arc sine? And if you've forgotten, it's 1 over the square root of 1 minus x squared. What's the derivative of arctangent? That's 1 over x squared plus 1. And what's the derivative of arcsecant? That's 1 over the absolute value of x times the square root of x squared minus 1. And a triangle, a right triangle, obeys Pythagorean theorem. A squared plus b squared equals c squared. So, if this is c and this is a and this is b, if I use these two, b would be c squared minus a squared would be the b squared. If I did these two, the a squared is c squared minus b squared. If I use these two, the a squared plus the b squared is the c squared. So one of these we get plus, the c is a squared plus b squared. The others we get subtraction, b squared minus c squared to get this one, or a squared minus c squared to get that one. We have 1 minus x squared. How would I make a triangle that would get a 1 minus x squared? Well, the hypotenuse would have to be 1, and I could put x on either side, and I choose to put it there. And then this side would be 1 squared minus x squared square root, which is kind of the triangle we drew when we were figuring out the derivative of arcs sine in the first course of calculus. If I wanted to get x squared plus 1, I would want to put x and 1 on the two legs, and the hypotenuse would be the square root of x squared plus 1. So I'll put x there and 1 there, and this would be the square root of x squared plus 1. If I was doing arcsecant, where I'm taking 1 from x squared, then I would want to put the x on the hypotenuse and 1 on one of the sides, and I'll put it down here, and then the opposite would be x squared minus 1. So if I'm trying to get something like this, my substitution would be the sine of theta is x over 1. If I was trying to get something that looked like this, my substitution would be tangent of theta is x over 1. If I was trying to do something that looked like this, my substitution would be not 1 over x cosine, it would be x over 1 is the reciprocal of cosine, secant of theta would be x over 1. So that's the general idea of how to choose whether you're doing sine of theta is something, or tangent of theta, or secant of theta is something. Now I'm going to make a triangle for this one. So my triangle, I'm subtracting, so the one I'm subtracting from has to go on the hypotenuse, and since it says 9, I'm going to put 3 on my hypotenuse. Then I like to put the x over on the opposite side doesn't have to be, but it turns out I could put it on either of the legs, but it makes a few less negative signs to deal with when you're doing the derivatives and the integral. So I'm going to put the x on the opposite, and if with that set up on the triangle and theta's there, this side becomes 9 minus x squared square rooted. And from this, I have across from my theta is x, and that's the hypotenuse. So my simple explanation is the sine of theta is x over 3. So I'm going to try to do trig sub with sine of theta equal x over 3. Now when we do regular substitution, the first thing we do when we figure out what we're making our substitution is we need to find out what the dx is going to be replaced with. So we take the derivative. So the derivative of sine of theta is cosine theta d theta, and the derivative of x over 3, or better yet, 1/3 x, is 1/3 dx. Now that's where we normally stop when we're doing u sub, but in trig sub we also have this mess that the whole reason we're doing this is because of this square root mess. We want an expression for it, and so I'm going to use it in relationship to the easiest side, and it looks like it's the 3. So I'm going to say the square root of 9 minus x squared over 3 is which trig function? Well, that's adjacent. That's the hypotenuse. Adjacent over hypotenuse is the cosine of the angle. I now have the tools, or the subs I need for this. So this becomes 1, or if I had a number here, I'd just pull it out so that it is 1. So, and I need to replace this square root of 9 minus x squared. That looks like it'll be 3 cosine theta. The dx looks like that'll be 3 cosine theta d theta. Just looking at this. And then we see that this simplifies pretty well. In fact, it becomes only d theta. What's the antiderivative of d theta? Or shall I say 1 d theta? Well, if it was 1 dx, it would be x. So the antiderivative of 1 d theta would be theta. And let's see, yeah, plus c. But theta we manufactured. We need to get back to x's. So now I need to go figure out what theta is. So I'm going to go back to this, and I'm going to solve for theta. To get rid of the sine, I do arc sine of both sides. And that says theta is the arc sine of x over 3. And that's the antiderivative of that. Okay. Now we did a problem in completing the square, and we came to an integral that said 1 over 3x squared plus 2. And we did some smooshing on this one. We factored out the 2 and made this 3/2, and then we put the 3/2 in there, made it the square root of 3 over 2 inside the square, and we came up with an arctangent. Let's just do it with trig sub now. So we don't have to do that smushing and algebra stuff to mess around with it. So this is a sum. So what would where would I put things on my triangle? Well, when you're adding, those two parts go on the legs, and the hypotenuse, they get added. I like to put the x on the opposite side, so I'm going to say, what would be squared? Well, see, that's going to have to be the square root of 3x. So when it's squared, it's 3x squared. And what am I going to have to put down here? So when it's squared, it's 2. Square root of 2. So if I took this and squared it, I get 3x squared. I square that, the a and b squareds, I get 2, and square root, and there's my triangle setup. So, using the simplest two sides, which are the two legs here, I see that would be a tangent of theta is square root of 3x over the square root of 2. So that's what I'm going to use for my substitution. So just like in u sub, we need to take the derivative. So the derivative of tangent theta is secant squared theta d theta. And the derivative of square root of 3 over the square root of 2 times x is square root of 3 over square root of 2 dx, or I can make it just a square root of 3 halves also dx. That's the same as square root of 3 over square root of 2. And the thing we always have to do with the trig sub is something that relates to this mess, which is this square root thing. If I use it and the simpler side, which is the square root of 2, if I write the square root of 3x squared plus 2 over the simpler side, the square root of 2, that's hypotenuse over adjacent, which is the reciprocal of cosine, which is secant. So now I'm ready to make some substitutions here. 1, leave it alone. If there was a number, I would have pulled it out. The 3x squared plus 2 looks like I would have to multiply by the square root of 2 and square both sides. So I would get the square root of 2 squared, which is 2, and the secant of theta squared. 2 secant squared theta would be 3 square root of 2 plus 2. I'll write that out. So I'd get square root of 3x squared plus 2 equals the square root of 2 times the secant of theta, multiplying both sides by the square root of 2, squaring both sides, and I get that. The dx, well, the dx is, I'm going to have to multiply by the square root of 2 over 3. So it's going to be the square root of 2 over 3 secant squared theta d theta. That's what dx is. And they don't always turn out this well, but this one, the secant squareds, completely cancel. The constants pull out, and I get 1/2 times the square root of 2 over 3 antiderivative of 1 d theta, which is 1/2 square root of 2 over 3 theta plus c. But this is manufactured. We have to go back and let's see. What was theta? Well, to solve for theta, I would take arctangent of both sides to get rid of the tangent. And so I get 1/2 times the square root of 2 over 3 arc tangent of square root of 3x over, I just extend it down, square root of 3 over 2 times x plus c. And that's what we got in class on that one problem that was real long, and this was one piece of it. All right, let's do one more. Let's do this one. This one will show you that it doesn't always come out to be 1 d theta like we had up here and on the other one. I'm going to do the antiderivative of x squared over square root of 9 minus x squared. Well, the square root of 9 minus x squared we already set up once. Maybe I should change that. No, I'll leave it like that. Okay, dx. So let's do this one. Going to ignore the x squared. The messy thing is this square root. And to make that less messy, I want to put, let's see, it's a subtraction, so I'm putting the part that's being subtracted from on the hypotenuse, the square root of it, so I'm going to put 3 on the hypotenuse. I like to put my x's on the opposite side, so I'll put an x over there. So the adjacent leg would be 9 minus x squared square root, just using the Pythagorean theorem. So my trig sub says the simplest ratio would be the sine of theta, the opposite over hypotenuse, is going to be x over 3. Taking the derivative, I get the cosine of theta d theta equals 1/3 dx, because x over 3 is 1/3 times x. Its derivative would be just 1/3 dx. And we make an expression for the messy, involving the easiest side, so I'm going to do, that's adjacent and a hypotenuse, so that would be the square root of 9 minus x squared over 3 would be adjacent over hypotenuse, cosine of the angle. So let's go to our problem. So we need to do the antiderivative. Now we can't ignore the x squared anymore. We've got to replace the x squared. What is x equal to? Well, it looks like it's equal to 3 sine theta. So x squared would be equal to 9 sine squared theta. What's that denominator equal to? Well, that's 3 cosine theta. If you multiply by 3, you get the square root is equal to 3 cosine theta. What's the dx equal to? 3 cosine theta d theta. We've made replacements for each piece. Let's simplify. Well, the 3 cosine theta and the 3 cosine theta cancel, but that x squared created this thing. So the 9 pulls out. And we have this. Now, if it's an odd power, it's easy to do u sub and undo the antiderivatives of trig functions like sine and cosine. But if it's squared, it's a little trickier substitution. But fortunately, I've given you a table that might help us do the antiderivative of sine squared. In fact, right there, the antiderivative of sine squared of some angle is the angle divided by 2 minus 1/2 sine of the angle, cosine of the angle, plus c. So, the antiderivative is 9 parenthesis x, in this case it's theta, divided by 2 minus 1/2 sine of the angle, cosine of the angle, plus c. Okay? So, again, we manufactured theta, so now we have to go back to x's. So we got 9 parenthesis theta. Looking at what we made it, we got to take the arc sine of both sides, so it's going to be arc sine of x over 3 over 2, or 1/2, however you want to write that. 1/2 times the arc sine, or arc sine of x over 3 all over 2, minus 1/2, what's the sine of theta? So I'm going to go back to my triangle and see what the sine is. See, sine is what side to what side? Opposite over hypotenuse, so that's x over 3. And cosine, that's adjacent over hypotenuse, so that's square root of 9 minus x squared over 3 plus c. And that is the messy, complicated antiderivative to this. Now, compared to where we just had 1 over 9 minus x squared, that turned out to be pretty simple. That x squared made it a whole lot messier. Now, one that tends to bother people, I'll do one more, my last one, is something that looks like this. Let's see, which one do I want to do here? I'll just do this one. The antiderivative of dx over 16 minus x squared to the 3/2 power. And that 3/2 power has messed up a lot of people on some of my tests. Well, let's just look at what we got. The half is the square root. And that's a cube. But it's a square root. And so let's just go ahead and we can't do u sub because it would create a 2x. There's no x to cancel it. So set up our triangle. And we got something subtracted from something. So the one that it's being subtracted from, the 16, has to go on the hypotenuse. 4 on the hypotenuse. I like to put my x's on the opposite, so that's going to be x over on the opposite. And this is looking real familiar. It's looking like a sine substitution. This is going to be the square root of 16 minus x squared. The sine of theta is going to be x over 4. The derivative is going to be cosine theta d theta equals 1/4 dx. We want something for the mess. The mess over 4 is going to be the cosine. Square root of 16 minus x squared over 4 is the cosine of the theta. And I'm set up now to do my sub. So I'll have the antiderivative. I'll put a 1 over this and put the dx out over here. So I got this, which is 4 cosine theta. That would be the square root. And this says square root cubed. So I'm going to have 4 cosine theta quantity cubed, because of the 3 in the numerator cubes the square root of this. And the square root is the 4 cosine theta. Got to cube it. And the dx is 4 cosine theta. D theta. Well, that's kind of sweet, because if we got 3 of them here and 1 of them up here, that would cancel and make it just to a squared. So I'd have the integral of 1 over 4 squared and cosine squared. So that's 16 cosine squared theta d theta. Now you're thinking, no, this doesn't look so good, right? Well, maybe it's not so bad. We'll pull the 16th out. Do we know the integral of 1 over cosine squared? Well, maybe we need to use our trig. What is 1 over cosine? Cosine is the reciprocal of, its reciprocal is, it's got a so it's secant. So this is just secant squared theta, d theta, because it's 1 over cosine squared. Oh, we know the antiderivative of secant squared. The derivative of tangent is secant squared, so the antiderivative, this is just 1/16 tangent theta plus c. And what is the tangent? Oh, we got to go back to our triangle. The tangent is x over the square root of 16 minus x squared. So there's one that looked like it was going to be ugly because of the 3/2. Turned out to be not even any arc tangents or sines or cosines in it. That's the idea of how to do these. The main thing is to know which trig sub to set your triangle up to start with, so that you can do your trig sub and follow the pattern of that triangle. Okay? Good luck.